In the previous episode, we discussed the shift from alarms to observation. Firestar was not conceived as another alert system, but as a device capable of preserving a timeline. Now the question becomes practical. How does Firestar actually observe its environment? How does it look for? And how does it distinguish the meaningful change from ordinary daily variation? In this episode, focusing entirely on that layer, the sensing architecture. Section 1. Two fundamental indicators. Firestar's sensing architecture is built around two core environmental signals, temperature and the smoke concentration. These two variables form the foundation of most modern fire detection systems, but in traditional alarms, they are used only as triggers. When temperature across a defined threshold, the device activates. When smoke concentration reaches a certain level, the alarm sounds. Once triggered, the system fulfills its purpose. But before that moment, nothing is preserved. Firestar approaches these same two indicators differently. Instead of treating them only as trigger points, it treats them as continuous data streams. Both temperature and smoke concentration are monitored at regular intervals. Both are recorded with synchronized timestamps, and both are stored in a way that preserves their progression over time. The signals themselves are not made. What changed is what happened to them. Section 2. Continuous recording instead of instant reaction. In a traditional alert system, the logic is simple. Below threshold, no event. Above threshold, emergency. Firestar does not change the basic alert function. It can still operate as a conventional warning device. What it adds is continuity. Every reading is part of a timeline. Instead of only knowing when the alarm sounded, the system retains information about what occurred beforehand. How temperature changed minute by minute, when smoke first appeared, to whether smoke increased gradually or suddenly, whether temperature rose before or after smoke concentration shifted. This creates something that standard alarms does not provide: sequence. Not interpretation, not prediction, but sequence. And sequence is essential when reconstructing how a fire developed. Section 3. Adding visual context. Temperature and smoke provide quantitative data. They tell us that something changed. They tell us how quickly it's changed. They tell us what order it's changed. But they do not show what the environment looked like at that moment. To add context, Firestar includes a visual capture function. Under defined trigger conditions, the system can record photographic snapshots of the environment. These images are time-stamped and stored alongside temperature and smoke data. The purpose is not surveillance, the purpose is documentation. When reviewing an event, a temperature spike paired with a corresponding image provides clarity that raw numbers alone cannot. Was there visible smoke? Was there flame development? Was the space already filled with haze? Or did ignition occur in a concealed area? The image does not interpret, it preserves. Section 4. Synchronization, data, and image. The most important element is synchronization. Each photograph is aligned with recorded sensor data at the exact moment. This means that when reviewing a timeline, investigators and homeowners can see the temperature reading, the smoke concentration, the visual condition of the space, all tied to the same timestamp. Instead of isolated data streams, the system creates layered documentation. Numbers provide progression, image provide context. Together, they create a clear reconstruction of sequence. Section 5. When reconstruction becomes guesswork. After a fire, one of the most difficult tasks is reconstructing what actually happened. By the time investigators arrive, the scene has already changed. Surfaces are burned, objects are displaced, windows may have shattered, water has altered temperature distribution, smoke has migrated. Even with expertise, reconstruction often depends on indirect evidence, burn patterns, material deformation, residual smoke staining. These methods are valuable, but they are interpretive. They tell us what likely happened, not necessarily what actually happened minute by minute. Now image having synchronized environmental data paired with a visual snapshot from the early stage of the event. Instead of asking, did smoke from before flame, was heat localized or already spreading, did ignition occur in open space or inside an enclosure, the timeline provides clues, the image provides confirmation. This does not eliminate investigation, but it reduces ambiguity. The differences between assumption and documentation can influence insurance determination, product liability evaluation, electrical fault analysis, risk assessment for future prevention. Without early stage reports, the beginning of a fire is often reconstructed backward. With preserved data, the beginning is documented forward. That distinction changed the quality of understanding. Section 6. Defining the device's role clearly. At this point, it becomes important to clarify what Firestar is and what it is not. It is not a predictive AI system. It does not attempt to classify fire types. It does not diagnose causes in real time. Its role is narrow but foundational. It preserves evidence of environmental progression by combining continuous temperature recording, continuous smoke concentration tracking, time-aligned visual documentation. The system creates a structural environmental archive. That archive exists before the emergency, during the excavation, and after activation. Most safety devices are designed to act at the moment of crisis. Firestar is designed to extend beyond that moment. It remains passive during normal operation. It alerts when the thresholds are crossed, and it retains what occurred beforehand. The system does not replace fire response. It strengthens post-event understanding. In that sense, Firestar occupies a specific position between detection and investigation, not louder, not more sensitive, but more complete. Now that we'll examine how Firestar observes and documents environmental change, the next critical question is durability. Recording data is meaningful only if the data survives. How is the information stored? How is it protected from power loss? How does the system maintain integrity under stress? In the next episode, we'll explore the engineering decision behind the data preservation and what transforms a recorder into a true black box. I'll see you in episode 5.